Hello everyone, myself Dr. Kodarkar CS from Department of Physics, Sri Siddheshwar Mahavidyalaya Mazargaon. Today I am going to discuss you about Lenards experiment. We shall study first contents of this Lenards experiment. First is photoelectric effect, then experimental demonstration of Lenard's method, then graphical representation of Lenard's method, and lastly we discuss Lenard's method to determine E by M of photoelectron. Firstly, we discuss photoelectric effect. Definition of photoelectric effect is: it is the phenomena of emission of electrons from the surface of metals when light radiations of suitable frequency fall on them. In this photoelectric effect, the emitted electrons are called as photoelectrons. In previous lecture, we discussed all about this. After that, we discuss about experimental demonstration of Lenard's method. In this experiment, A is anode, C is cathode, B is uniform magnetic field, G is glass tube, V is potential across cathode and anode, W is quartz window, UV is ultraviolet light, E1 and E2 are electrometers, and P1 and P2 are metal electrodes. In this experiment, when ultraviolet light pass through the quartz window and fall on the surface of cathode, which is made up of aluminium, then the ray falling on the surface of cathode emits photoelectrons. These photoelectrons are attracted towards anode, and at the anode, at center of anode, one hole is present. Therefore, these rays travel towards plate P1 and electrometers E1 shows deflection. When we apply magnetic field on that photoelectrons, which is denoted by dotted circle, the ray coming out from the cathode or the photoelectrons which are coming out from the cathode travels in straight path towards anode. After that, they does not goes towards plate P1, but they travels towards plate P2, and electrometer E2 shows deflection. This magnetic field is denoted by dotted circle. Due to magnetic field which is perpendicular to electric field, the photoelectrons, after traveling through the holes of anode, goes to curve path towards P2, and this part A to P2 is nothing but it is an arc of certain circle. Therefore, in this experiment, when we study this experiment and we shows graphical representation of Lenard's experiment. This is the graph which gives a relation between current and potential of cathode voltage. On x-axis, potential of cathode voltage is present, and on y-axis, current is present. In first case, if high positive potential V is applied to cathode, means when we make cathode is more and more positive, that times anode becomes negative. The photoelectrons which is coming out from the cathode does not goes towards anode, and the current is 0. In second case, if the positive potential is further decreased, the current is increases. And lastly, if the negative potential V is applied to cathode, means when we make cathode is more and more negative, means anode becomes more and more positive. Therefore, the electrons which are emitted from the surface of cathode attracts towards anode, and current goes on increasing, and it reaches to a maximum value. After that, using this Lenard's method, we can determine E by M of photoelectrons. In that method, we can use magnetic field, and ultraviolet light is also used. To deflect the photoelectrons, magnetic field is used. In this case, capital V is accelerating potential, means it is a potential between anode and cathode. Small v is velocity of photoelectron, small m is mass of photoelectron, small e is charge of photoelectron. EV is nothing but force due to electric field. The electron travel from cathode to anode, means it produces kinetic energy. Therefore, kinetic energy of photoelectron is E multiplied by capital V. But all of you know, student, kinetic energy is equal to half mv square. Therefore, putting value of kinetic energy, we get half mv square is equal to small e multiplied by capital V. This is our equation number 1. When we apply magnetic field on the photoelectrons, what happen? This capital R is radius of circular path described by the photoelectrons in magnetic field of strength capital B. Then, due to this curved path of photoelectron, centripetal force required for circular motion is equal to magnetic force. And we know that mv square divided by r centripetal force is equal to BeV. BeV is nothing but force due to a magnetic field. Therefore, cancelling both sides V, we get mv divided by r is equal to Be. Using this equation, we can calculate V is equal to BeR divided by small m. Squaring both sides of this equation, V square is equal to B square E square R square divided by m square. This is our equation number 2. Putting this value of V square from equation 2 in equation 1, we get, all of you know, equation 1 is half mv square is equal to E multiplied by capital V. Therefore, half m, putting value of V square in bracket, B square E square R square divided by m square is equal to small e multiplied by capital V. Cancelling both sides E and m, we get half B square E R square divided by m is equal to V. Using solving this equation, we get E by m is equal to 2V divided by B square multiplied by capital R square. Using this value of capital V, capital B and capital R, where capital V is nothing but potential between cathode and anode, capital B is nothing but magnetic field, and R is nothing but radius of circular path described by a photoelectrons in magnetic field of strength B. We can calculate the value of E by m. The value of E by m is same that of electrons. It means that the particles emitted from cathodes are electrons. Using this Lenard's method, we can determine E by m of photoelectrons. We can stop here. Thank you.